Hello friends, welcome to Risingpearl.com. Today we are going to take a look at question number 17 that appeared in 2016 CBSE Class-X Math exam and how do we solve this question. So the question goes like this. A conical vessel with a base radius of 5 cm and a height of 24 cm is full of water. This water is emptied into a cylindrical vessel of base radius 10 cm. Find the height to which the water will rise in the cylindrical vessel. So we have to find the height to which the water will rise in the cylindrical vessel. So as we can see, there are no figures or shapes given, or the diagram is given to us. So we are going to draw a diagram for ourselves. Now we have a conical vessel, and the conical vessel is full of water. It's filled with water, right? And we have a cylindrical vessel, and we pour the water from the conical vessel into the cylindrical vessel. So let's draw. First thing is we are going to draw a cone. This is a conical vessel. Why have I drawn it upside down? The reason I've drawn it upside down, you could have drawn it the other way around as well, because this is filled with water. If I make it drawn, if I draw it upside down, doesn't make sense because the water is not going to be held inside the cone. And after we have drawn a cone, we also would need to draw a cylinder. So this is our cylinder. So what we have is this, so this cone is actually filled with water. Water is filled till the very top of the cone, right? And this water we are going to take, and we are going to assume that the cylinder is empty to begin with. So what we are going to do, we are going to take this water and pour this entire thing inside the cylinder, right? And then once we pour it inside the cylinder, so the water will rise to a certain level inside the cylinder, right? Because when you pour the water inside the cylinder, then the water will rise at a certain level, and the question is asking us that what is the height to which the water will rise inside the cylinder. So that is the question. So let's see what all is given to us, and we go from there, right? So the first thing is that the base, so this is a cone, the base radius 5 cm. So this is a cone, this is the radius, and this is 5 cm. This is given to us, right? And the height is 24 cm. So the height of the cone is this height. Now this height of the cone is given, and this height is 24 cm, right? Now for the cylinder, what is given to us is that the base radius is 10 cm. So for the cylinder, so if this is the base radius r, this is given as 10 cm, right? Now what really happens? What is the commonality? When we have water and we pour this water inside here, and the water level rises to a certain amount. So what is the common link between the cone and the cylinder? The common link between the cone and the cylinder is the water, because the cone is filled with water and the same water is poured into the cylinder, right? So what we can say is the volume of water, right? So volume of water is the same. So this will be the same in the cone and in the cylinder, correct? So if the cone is filled with water, then volume of water in the cone will be equal to the volume of the cone. And we know the formula for volume of cone is 1/3 pi r squared h, where r is the base radius and h is the height, right? So if we simply substitute this, so we have 1/3 times pi times, what is the radius? Radius is given as 5 times 5 squared times height is 24. So this is going to be the volume of water in the cone. Now let's give ourselves a little bit more space. So now that the same water is transported into the cylinder, so at this point the cylinder has certain amount of water, right? Now say that the height to which the water level rises in the cylinder is h. Now if we know the radius, which is given as 10 centimeter, it's given as 10 centimeter, and if it rises to level h or height h centimeter, then what is the volume of water inside the cylinder? We know that the volume of cylinder is pi r square h. This is the formula to find out the volume of a cylinder. So if the water level rises to a height h, that means the amount of water which is in this part that I am actually highlighting, how much is the amount of water which is in this? So that is going to be given by pi r square h, if h is the height to which the water level rises. Now this value then must be equal to what we just found out for the volume of the cone, right? So in other words, pi, let's put, instead of r, let's put 10. So pi 10 square times h must be equal to 1 by 3 pi r square, r here is 5, r here is 5, square times height is given as 24, we just saw that, right? So if we just solve this, we will be able to find out the value of h, which is what we need to do. So pi and pi will cancel out. So let's write it over here. So we have h equal to, so 10 square will come to the denominator because we're going to do cross multiplication, right? So the numerator will be here 5 times 5, just opening it up. So 5 square is 5 times 5 times 24 divided by 3, which is here, times 10 times 10, right? So 5 ones are 5, 5 twos are 10, 5 ones are 5, 5 twos are 10. So now this will be 3 times 2 is 6 times 2 is 12. So 12 twos are 24. So 3 times 2 times 4, 3 times 2 times 2 is 12. 12 twos are 24. So we are going to have 2. So or 2 centimeter. That means when we pour the water in from the cone into the cylinder, the water will rise to a height of 2 centimeter. This is how we solve question number 17.